Unit 3, we're going to be discussing triangles, and we're going to learn a lot about the different types of triangles and angle measures and other things about them. And so we need to start off by defining a triangle. And a triangle, the actual technical definition, is that it's 3 segments connecting non-collinear points. All that means is I have 3 points that are not in a line, and then there's line segments connecting them. So that would be a triangle. Now our triangles can look a bunch of different ways. You can see triangles like this. You can see triangles like this. You could see triangles like this. There's not really a specific way that a triangle has to be drawn. A triangle just means it's got 3 sides. And not only does it have 3 sides, it also has 3 vertices. And the last thing is that it has 3 angles. So looking at this particular triangle here, if I were to label everything, I would first of all label my sides. And there are 3 of them. The next thing I'll label my vertices. It might help to understand what a vertice is. A vertice is a corner. It's a point. So these are my vertices. And the last thing is my angles. And my angles are on the inside, and they're formed by the connection of 2 sides. So I'm going to label just angles here, then I'm going to draw lines going to each of those. So those are the 3 parts of a triangle. So looking back at this triangle, I've cleared out everything that was written there. It's important to note that I have if I have angle A being this angle right here, the side that is opposite of angle A is side BC. Opposite means that it's across from and doesn't touch. Means it's across from and doesn't touch. So this side BC would be across from angle A. The next statement says angle A is included between sides, and that's basically asking what sides make it up. Well, this is angle A right here. The 2 sides that connect to form angle A are sides AB and sides AC. When we start naming triangles, the naming of triangles just means that we call it by its letters, and it doesn't matter where we start or what direction we go. What matters is that we go in order. And we talked about this a little bit when we were naming polygons. So this could be triangle DEF. This could be triangle EFD. This could be triangle FDE. This could also be triangle DFE. This could be triangle FED. Or this could be triangle EDF. Again, it does not matter which point you start at, and each of these has a different starting point and goes a different direction. So the first one, DEF, starts here and goes this direction. Our last one starts at point E and goes this direction. And that's just how you label them. As you start somewhere and you go one direction, you just list all your points that are there. So there's three specific types of triangles we're going to talk about that are determined by angle measure. So these are determined by the angles. There are acute, right, and obtuse. An acute triangle is a triangle in which all angles, every single one of them, is less than 90 degrees. So an acute triangle is a triangle in which all angles are less than 90 degrees. A right triangle is a triangle that contains exactly means only one 90-degree angle, or one right angle. And an obtuse triangle is a triangle that contains one angle and only one that is greater than 90. So if we look at this picture here, the first one, we have angle measures of 40, 60, and 80. So we have to decide, are all of them less than 90? Is exactly one of them 90, or exactly one of them greater than 90? Well, 40, 60, and 80 are all less than 90, so that makes this an acute triangle. If I look at the next one, I have angle measures of 27, 90, and 63. So again, I have to decide, are they all less than 90? Is it only one equal 90, or only one greater than 90? In this case, I have one that is exactly 90, so that makes this a right triangle. My last angle, I have 120, 35, and 25. Again, I have to decide, are all of them less than 90? One of them exactly 90, or one of them greater than 100, or greater than 90? And in this case, one of them is greater. One of them is 120, so that makes this an obtuse triangles. So that's the first way you can classify triangles, is by angles. The second way you can classify triangles is by side lengths. So these next three options we're going to learn about are determined by the sides. So an equilateral triangle is a triangle with all equal sides. So an equilateral triangle says every single side is exactly the same. It's important to note that an equilateral triangle is also equiangular. If all the sides are equal, then all the angles are equal as well, and that's what the word equiangular means. An isosceles triangle is a triangle with at least two equal sides. Now, that phrase, at least, is really important because at least means the minimum amount is 2, but it can be more. So that means 2 sides could be equal, 3 sides, 4 sides, 5 sides, 6 sides, 7 sides. As long as 2 of them are equal, it's considered an isosceles triangle. Now, in a triangle, it can only either have 3 sides. So that means if it's an isosceles triangle, that means either 2 sides are equal or 3 sides are equal. So this question says triangles that are equilateral are also isosceles. That is true. If it is equilateral, that means that it is also isosceles. And our last type is scalene, and scalene is a triangle with no equal sides. So all the sides are completely different. All right, so this page 19 is about determining the 2 side lengths, or the if something can be a triangle. So here is our rule on side lengths. You pick 2 sides. And the rule says that side 1 plus side 2 has to be greater than the third side. And the other part of that is that side 1 minus side 2 must be less than the third side. So you add the two sides together. They've got to be greater than the other one. You subtract them, and they have to be smaller than the other one. So starting with this first one, it says, it is possible to build a triangle with side lengths of 3, 3, and 3. So the first thing I'm going to do is I'm going to add 3 and 3, and I'm going to get 6. Then I'm going to subtract 3 and 3, and I'm going to get 0. That means that my third side has to be between 0 and 6. It can't equal 0 and it can't equal 6, but it has to be between 0 and 6. So as long as this third side is between 0 and 6, we're good. And 3, last time I checked, is between 0 and 6. So yes, this could build a triangle. The next question says, is it possible to build a triangle with sides of 3, 3, and 9? Well, thinking about what we just figured out, if one side is 3 and the second side is 3, then we know that our third side has to be between 0 and 6. 9 is not between 0 and 6, so 9 could not be a third side. What that would look like, just to kind of give you a picture, would be if I had a little bitty side of 3, and a little bitty side of 3, and then a really long side of 9. That would not fit together, no matter how you tried. Okay, then it says for the third one, true or false, it's possible to build a side with triangles of 7 and 6. So I'm going to do 7 plus 6, which is going to give me 13. Do 7 minus 6, which is going to give me 1. So that means my third side has to be between 1 and 13. It can't equal 1, it can't equal 13, but as long as it's a number between 1 and 13, we're good. And 9, this third number here, is between 1 and 13, so yes, it can be a triangle. I want you to find some space to write this down because this is very, very, very important. So we're going to make a table. When we're classifying triangles, we classify them one of two ways. The first way we classify them is by their angle measures. And the second way we classify them is by their side lengths. On your quiz today, or in one of your quizzes, they're going to give you a triangle. And they're going to ask you to tell us what kind of triangle it is. And they're going to give you 5 to 6 different options. And you can pick more than one of them. So the first thing is that every triangle is either acute, obtuse, or right. Now our side lengths can be scaling, isosceles, or equilateral. It's important to remember, if it's equilateral, it is also isosceles, but the other direction is not true. If it is isosceles, that does not make it equilateral. There is one other type of angle you can have, and that is equiangular. If it's equilateral, it's also equiangular. They're the same thing. And if it's equiangular, it is also acute. Equiangular means all the angles are the same. If all the angles are the same, that means they're all going to be 60 degrees. And that falls under the rules for acute triangles. Question 1 on your checkup says, which triangles are acute? Recall that acute means that all angles are less than 90. Now, for some of these, it's really easy to tell. Like C, they give you angles of 80, 40, and 60. You know without a shadow of a doubt that it is acute because every single one of those is less than 90. But the rest, they don't give you all that information. So there's some things you need to know. Starting with A. When you see these lines on the sides, these lines tell us that these two sides are the exact same. And there's a rule in math that you'll learn in a couple of sections that says if two sides are the same, the angles across from them are also the same, so the angles they point to. Well, this points to this one, this points to this one, so they both have to be 70 degrees. That's the first thing. Second thing you need to know is that, and this again will come up in, I think, the next section, all the angles of a triangle add up to 180. Your quiz will not be this difficult, by the way. So if these two are 70, then 70 plus this angle, I don't know, I'm going to call it x for now, has to add up to 180. 70 plus 70 is 140. And if I did a little math, I'm going to determine that this angle is 40 degrees. So knowing all of that, we now know that triangle A is also an acute triangle because every single angle there is less than 180. For B, they tell us this is a right angle, means it's 90. So this one's 30. I'm going to help you out and tell you this other angle is 60. For triangle D, they tell us these two sides are the same. If these sides are the same, that means these angles are the same. They're each going to end up being 20. For triangle E, they tell you all these sides are the same, which means all of our angles are the same. They're all going to be 60 degrees. So that means E is also going to be considered an acute triangle. Number 3 says which triangles are scalene. Scalene means all the sides are different. And if all the sides are different, it also means all the angles are different. And again, this is not something you're going to have to know for the, you don't need to know that for this quiz, and it's going to come up later on. But again, if all the sides are different, that means all the angles are different. So we can look at this, and B has all different angles, so B would be a scalene triangle. C, all the angles are different, so that would be scalene, and that would be the only two. Number 5 says which triangles are equilateral. Equilateral means all sides are exactly the same. There's only one of those, and that is triangle E. Number 7 says what angle is included between sides AB and BC. So that means if I were to connect AB and I were to connect BC, what angle do they meet at? And they meet here, and this would be at angle B. Number 9 says if AB is 5 and BC is 10, is it possible that AC is 4? So what that's telling you is if you have a triangle of sides A, B, and C, where AB is 5, BC is 10, can AC be 4? Is that possible? So the rule says, if you remember, that we have to take the two sides and add them, and they have to be bigger than the third side. And we have to take the same two sides and subtract them, and that has to be smaller than the third side. So I'm going to take my first two sides of 5 and 10, and I'm going to add them. 5 plus 10 is 15. Then I'm going to take those same two sides and I'm going to subtract them. But I'm smart. I know that if I do 5 minus 10, I'm going to get something negative. And I do not want something negative. So I'm going to write this as 10 minus 5. Because 10 plus 5 and 5 plus 10 are the same thing. 10 minus 5 is going to give me 5. So what I know about my third side is that it has to be between, cannot be equal to, but can be between 5 and 15. So you have to ask yourself, is 4 between 5 and 15? The answer is no. So this could not be the third side.